Hello everyone, welcome back. My name is Rafael Scala. Thank you for watching this video. Today we will continue doing the video series talking about the design data intensive application book. This is the early access, the 2026 edition. And the topic of today is scalability, right? And scalability is a engineer decision with multiple trade-off and multiple ways to grow and scale, okay? But you have to take in mind that when you are working on an application, it will receive an average trade-off or response time that your application is supported, right? But when in the this application is growing and is have more popularity for the customers, there will be a trend to receive more requests, more it will demand more resources because it's an application that is live, right? So in that case, maybe you have to take in mind if you really needed skill and you have to take the measurement that you already have to take the best decision to how to do it, or if you needed to do it actually. It's in a trade-off because not all the growing or scale your application will have a advantage, right? Because all them have a disadvantage, and you have to take a note that is better for you to implement, right? So take a note that in summary that equality is when you are copying and increase a load that I said before. There is a performance degradation that you want to prevent, so you have to prepare if the data volume is prepared to support that, right? And it's not a binary label. It's not like, okay, Redis is a scale, Kafka is a scale. No, it's another one is not a scale. No, it's not like a take a decision if that is scale and that is not a scale. Is that the scalability is only include that to ask the correct question that you for your application to know if you have multiple options, right? Or which one is the option that you will have to decide it if you need to scale. But the main thing is to define it. What is the bottleneck? What is the component that is critical for you to need to be have a good performance? What is the service level agreement that you need to support to have a good response time? So that is the thing that you have to do when you are trying to do scalability. It's not only focus on the tool that you have to know if it's scale. Is the question is in the context of your application, you have to ask the good question, right? So that's it in summary. And the first thing that you have to note, because I am taking a note that you are deciding that your application need to grow because you feel that, okay, maybe there is a response time that it could be a symptom that maybe we need more resources and need to be defined the implementation or the architecture with another way to grow, right? So take that in mind. So before to decide it, which element it will be refactoring or it will be increment, right? Or growing. First, we have to understand what is the current measurement that you already have in your system to decide which part it will be better to invest the resource. So in this case, the first step is to understand what is in understanding loaded right in your system, and you have to take some parameters that in your system you need to um, check, right? So the first thing is the throughput. Obviously, is a measurement that is easier to get if you already know how traffic you regularly you have in your system, right? And the request per second, actually, that's it. The volume that you have on your for each user in that you have in your system. I mean, usually the average user in your system will have several rows, right? Or a small database or a small volume of data, so that it will be impact in the way to you will grow, because actually the resources that it demand to write in a database that is a huge number, they have a huge number of the rows, it will be worse if you have a small database and there are heavy number of requests per second, right? So there is a difference about that. And how many user is connected on live with concurrency? That means when, for example, you are trying to support WebSocket or multiple uh, threads or multiple message at the same time. So that metrics is very important to know. And the patterns, right? If there are more number of the reads query or versus the write ratio, right? That you want to support in your system, right? So that's depend of your context of your application. That's the main goal that you have to define. The next thing is when you already have the metrics that you already know that, okay, that is a symptom of something that maybe it could be better or there could be a problem in the future, then you have to think what will be the behavior of the throughput and the response time if we will have, I don't know, um, two times of load of the if you have an incremental of the load two times, right? So what will be the expected that you have in the throughput and the response time, right? So with that, with the calculation that I explained before, when we were talking about a performance metric, you can calculate what will be how many key request it will be have this delay, right? Because when you have a high number of throughput and your system, your core have a limited number of thread that supported to be have an processing, right? There are requests that it could be stored or be in the queuing stage. So in that queuing stage, it will increment the delay of the response time. So you have to calculate what will be happen if your system growing 10 times or 2 times, I don't know, and what will be the expected in the performance that you will receive, right? So that is the first question. And the second question is, okay, how many resources that you need to maintain the current performance that you have in this moment if the traffic it will growing. So with that question, you will decide if you needed to grow and how to do it. And actually, when you are trying to define how many resources, you have to take a note that the best decision is if the cheapest way to define which resources it will be better for your application to keep the same performance that you already have in this moment. So that take a mind. It's not all the infrastructure decision of implementing your application. It will be better. Actually, the better decision it will be the usually the cheapest because but only I am talking about the budget topic because there are others factors that it will impact in the decision of the scalability, right? So that's it. So okay, maybe you have to take a note that what will be the performance impact in the future, right? But the next thing it will be the architectural approaches that maybe you can take to handle the scalability, right? So the first thing that maybe the easier way is a vertical scaling. That is very common decision when you are working with a monolithic, for example, and when you are sharing the same memory, the same CPU, and everything is stored in the same server, and only the unique way to grow in this case is only to buy more resources or invest in more resources, more RAM or more CPU to increment the load. But the problem of this decision is because it's not linear scalability. It's like if you want to grow 2 times of load of your traffic, it's not necessary to increment the spend of your resources 2 times because actually it will be expensive to have a, a growing of memory than to have two servers with a low cost memory. Actually, that is the problem of scale vertically. You need to is usually is most expensive, right? So that is that disadvantage to handle it vertical scale. I don't say that it's not a is not is, vertical scaling have a solution that is obviously you need to scale very fast. You don't want to care about that the complex of a distributed system, but you have to take a note that trade-off, right? That is a decision. And another thing that is another way to have an architectural approach is shared disk architecture. Is when you have an disk storage. I mean, when you have a file system storage and you want to keep, it's like when you have an array of files, right, in a file system storage, and multiple nodes or servers is using the same file system, right, or array of file system servers, right, of this storage, right. Uh, the advantage of this one is that it is very fast to receive the updates that you are doing in this disk file system, right? Because if you update in a file, you are updating a real file. But the problem is that you will you have to take care of the part of the locking contention limit, because actually there is no way to uh, two threads trying to modify in the same file, because there isn't a locking when you are writing a same file. So you have to keep the part of concurrency. That is obviously disadvantage of this approach, but the advantage of this is that um, it will you don't need to take care about the eventual consistency when you are updating a file. The file that you are updating, that is very fast, and you can actually update with offset, right? Because not necessary to update all the file, you can use the offset. That is concept is coming when you are working with file system on Linux. But the idea of that is very fast, but the problem is that you have to take care about the locking, right? So that's it. And this approach is when you share the same storage array, or it's called also um, NAS, right? It's Network Attachment Service, right? So that's it. This is another way to scale. And another way that is very popular currently is horizontal scaling, right? Or scaling out, right? When there is nothing that is sharing in this server, it's like any all the nodes, all the servers that is, or all the replication that you have in your system of the distributed system is isolated with own disk storage, memory, and CPU, and that, right? And if we are talking about a microservice, each microservice have their own database, so the idea is to be isolated. The advantage of this is that if you want to grow with this architecture, it will be linear scalability. So if you want to grow twice the traffic of to support in your system, you only need to create more replicas, and you instantly will support more traffic. So it's cheaper, but the problem is that you have to take care about the part of the complexity of the distributed system, right? You have to take care of the part of the latency, because the communication between multiple distributed system or nodes needs to have a network communication of each communication of networking. It have a latency, right? So that concept we will see it on the performance metrics, but that is the idea. So it not will have you have to take care of the part of the eventual consistency, right? Because we have the data have to be synchronized in multiples process, or in multiple microservices. So that's it. And another problem that maybe you have to take note if you decide to use the horizontal scale. And well, there are multiple solutions to take this distribution, or, using sharding when we're talking about databases, or actually you can sharding in servers according keys, right? So you can decide that, or creating a batch processing to handle the streaming of data, right? So that's it. And this is that architectural approaches that you can use. And there are design principles to work with scalability, right? That you have to take a note to work with that. And the first thing that, in summary, this is a summary that I'll tell you before, that when you are trying to prepare first to tackle an scalability with a system, you have to take note that if your system really need, because maybe in this moment you are working in a startup, you have a small team, and you have a growing, you growing, not is not a, a peak of trend, right? So you are growing, but consistency, right? Not need to take care that tomorrow it will be a peak of traffic or something like that. Maybe you don't need to create. You don't need to worry about the scalability, because like, to think about scalability, it will take time to take that simulation, the decision actually, with maybe that at the moment of the business is not necessary. It's not a priority in this moment. Maybe you only need to take care to, and when you are starting the application, maybe it's better to only focus what really what is the needed that the customer, that you are trying to resolve with your application. Maybe it's better to know, to understand your customer actually, instead to worry about what will happen if tomorrow we will have a peak of traffic, right? So that is the first question. Try to keep it simple, to not spend time and resources in something that in this moment you don't need it actually. So that's it. So to try to optimize or scale when you prepare to do it, first, as I said you before, you have to understand the load, then select the architecture that you want to define it, you want to use it, and obviously you have to define the bottlenecks that you think that you need to scale, right? And evolve. You have to monitor every time, because you have to maintain the measurement that you already have, right? That you have to keep the measurement that you already have. I mean, the throughput, the response time, and everything, right? So that's it. And you have to, when there is an order to improve the traffic, and you have to think that when you are growing, the loading, it will be a magnitude. I think there is a theoretical concept that if you are growing 10 times, you have to think that your architecture, it will change. So it's better to only think, maybe if you are imagine that you are growing only one of time, right? If you are growing once time more, because if you're thinking, okay, what happens if I have 10 times of growing or 10 times of traffic or throughput, obviously your current architecture, it will need to be refactored. So don't spend time in that situation if you really, your business doesn't need it. Okay, take a mind of that. And the next thing, there is not a generic decision about how it will be the best scale, or a roadmap that what will be the scalability for a generic application, because it will be the same decision if, for example, you have a system that have a 100,000 of requests per second versus uh, 3 requests per minute, but with 2 gigas of size per request, right? So that system need to have a different scalability. So you have to take in mind that there is not a generic decision. You will not try to only decide it using tool. Instead of that, you have to understand what is the context of your application, and then you have to research or investigate what tools you have availability to use. You have to take note what is the disadvantage of each tool, that in the current um, context you really need it. Okay, so not only think about that what is the trend tool that is um, cool in this moment, right? So that's it. And there is another very important problem, that when you are working with a microservice, not only just to split the code, is like decided which part of your application will need to be isolated in another microservice. It's like you have a monolith and you want to and create microservice, maybe you have to take note which part or element of your business of this monolith have to need to be in another microservice. So that is another thing that you have to, isn't a challenge that you have to decide it when you are scaling. That is not part of the resources. That is important to scale with the software, right? Because not you don't want to have an bottleneck because you split the business, your monolithic, that is not flexible. So that's it. And in summary, yeah, take a note of that. If you decided to scale before, and thank you for watching this video again, and see you later. See you in the next video. Bye bye.